Hey kiddos. Today we're going to be talking about surface area and volume. So, what we're going to be mainly dealing with are polyhedrons. And a polyhedron is basically a straight-sided solid shape. It usually comes from our two-dimensional shapes that we've, or polygons, I should say, that we have kind of already talked about. So that's kind of what a polyhedron is. Polyhedrons have three important features. That is the vertex, so that's the corners, okay? We have the edges, which you can see here is that red line. That is an edge, or you can also kind of, in a sense, imagine it's a side. And then the last one is, technically you can call them faces, but more specifically what we're going to be focusing on are bases, okay? Having a base. Now, this is probably what's going to be the more complicated part of figuring out is, well, what is the base of certain three-dimensional shapes that we're going to be talking about? And one way to note which one's the base is if there's one, how do I say it? If there is only one shape, so here's a better visual. So let's say I have a pyramid, okay? I know it's a horrible drawing, don't judge me. Because it only has one square, okay, or rectangle, that would be deemed as the base for this three-dimensional figure if I were to actually put it all together, okay? So notice this is called a net because I drew a three-dimensional figure flat, okay? So if I were actually to prop up these four triangles up, then create that pyramid, and this would be the base. Okay, it's the base because there's only one of it, and it's also the base because that's what this three-dimensional figure actually sits on. All right, so that's another way to figure out what a base is. Another way is also if there's two of the same shape, then that could be another way to determine what the base is. A lot of times in a picture, if they set the picture, for example, like this, then we would just go with this being the base. Obviously, it can have two bases, all right? But for our purpose of our formulas here, you only really ever have to find the base, the area of a base one time, okay? But notice if this were flipped on its side, so if we were to flip this over, and then this is what it was like sitting on top of, then this would be the base, and that would be a base, okay? So it also just depends on how your picture is set. So hopefully I didn't just confuse you about how to figure out bases. It's really not that hard or complicated, I hope. Another feature that we're going to be talking about, okay, are curved kind of polyhedrons. And in this case, this is a sphere. Now, spheres do have a radius, okay? And then if you notice the circle here that's marked, we actually have a special name for that circle, and it's known as the great circle, okay? So just features I wanted you to know about the sphere itself. Now, what we have here are formulas, okay? So again, we're going to be talking about surface area and volume, okay? So surface area, we have two different types of surface area. We have lateral and we have total, okay? Lateral just really means it's basically everything but the bases, okay? That's what lateral means. Everything but the base. And total includes the base. That's really the difference between lateral and total. So we have prisms, and we do have a few different types of prisms. You got rectangular prisms, cubes, and triangular prisms. So to find their information, you would use that surface, the lateral surface area is equal to capital P times H. Now here's something that you may want to make note of. Capital P stands for perimeter of base, okay? Lowercase h stands for height. Let's see, what other figures do we have here? This cursive L stands for slant height. Okay. If you see lowercase r, then stands for radius. Pi, unless told, you will either use the pi button in your calculator, or if they tell you specifically, you can use 3.14. But remember, you'll be told which one to use. And I think the other one is capital B. Capital B stands for the area of the base. Okay, so these are all definitions that you need to understand when we're interpreting all of these formulas. All right. Usually when I ask for lateral surface area, I'll put LSA. So that way you know it's lateral. And if I do total surface area, I'll usually do TSA. Volume's pretty self-explanatory. It's just a V. Okay, notice they use also very similar letters here. So it's important that we understand that. You also need to add a hemisphere. Okay, notice the sphere is the only shape here that does not have a lateral surface area, and that actually also applies to a hemisphere. Okay, hemisphere is essentially half of a sphere. So neither one of them have lateral surface areas. They only have total surface areas. So here are the formulas for the hemisphere for surface area. And like I said, that's total, so you may want to make sure you note that. And then the volume for a hemisphere. So make sure you jot those down. All right, so the first example we're going to look at is a very special type of prism. It is the cube. Now, I know it's a cube because it tells me that all these sides are congruent, okay? So, notice I took the time to write all my formulas that correspond to a prism, because that's what this is. This cube is a prism. So, we're going to be looking for the lateral surface area, total surface area, and the volume. So, this is everything I need to solve it. So, really, it's just three things I need. I need to know the height of it, what the perimeter of the base is, and what the area of the base is. So, the height of this prism is going to be 8. Now, if you want to draw the bases separately away to help you identify it, that's totally fine. Notice I went ahead and I actually highlight it so we can note. This one's pretty simple to identify because it's the one that's on top of, the one that's set on. So I know that these measurements are all 8. So therefore the perimeter would be either 8 times 4 or 8 plus 8 plus 8 plus 8. And that gives me a grand total of 32. Then the area of the base would simply just be, because it's a square, base times height, which is just 8 times 8, which means that the area is 64. Now that I have all that information, I can just simply plug it into the formulas to figure it out. So let's look at lateral surface area first. It simply says that we're going to take our perimeter of the base and we're going to multiply it by the height, which is 32, which was our perimeter of the base, times 8, which is the height. And when we do that, we get a grand total of 256 centimeters squared. So now let's move on to the total surface area. And notice it actually, the first part of the total surface area is the lateral surface area. So you can either go ahead and write in that value, which we already know that answer was the 256. Or if you need to actually take the time and rewrite capital P times H, that's totally fine, okay? I'm just going to kind of skip that step since I know it's P times H, which I already know the answer to that, okay? Then from here, the formula says we're going to add 2 times B, all right? So when we work this out, we'll have 256 plus 2 times B in our area of the base, 64. So when we add that, 256 plus 2 times 64, we get a grand total of 384 centimeters squared. Now for the last one, volume. Volume is capital B times H. Well, we know the area of the base was 64, and 64 times H, which is the height of this prism, which was 8. So 64 times 8 means that the volume is 512 centimeters cubed. All right, looking at the next problem, okay, we have again, it's a prism. It's a rectangular prism, though, because I can see the base is a rectangle instead. And we have these measurements here. So we're looking for those three things again. So notice in those formulas, I need a height, perimeter of the base, and area of the base. I went ahead and drew my base separate, so it makes it a little bit easier for me to find the two things I need, which were the perimeter of the base and the area of the base. So I'm going to fill this in. All this information I got from the original picture. The height of this prism is 15 centimeters. So the perimeter is 20 plus 20 plus 12 plus 12, which gives me a perimeter of 64. And base is just the length times width, or base times height here, which is 20 times 12. And the area of the base is 240. All right, now we're just plugging it in to our original formulas. And I'm actually going to have you guys do that on your own. All right, so hopefully you guys were able to figure out that rectangular prism. Now we're moving on to a sphere, okay? So for a sphere, notice I already made note here that the lateral surface area doesn't exist for a sphere, so I just went ahead and put NA. It's not applicable for this shape, okay? So all we have to look for is the total surface area and the volume. Now, always write your formulas, okay? So I have my formula written down. And the only real piece of information I need to know is what the radius is, okay? In this problem, we're going to use the actual pi button in our calculator, okay? So please make sure that you do that, because if not, you will get a different answer. So radius, notice I see they gave me that the whole thing is 12, which is the diameter. Radius is half of that, so I know my radius is 6. So now, let's find the total surface area by plugging in what we got. So we have 4 times the pi button times the radius squared. So 4 times pi button times 6 squared gives me an answer. And you guys should hopefully know by now my favorite number to round to is the 10th spot. So we get an answer of 452.4 centimeters squared as the area, or total surface area, for a sphere. Now for the volume, we have 4/3 times the pi button times the radius, which is 6, cubed this time. I always like to put my fraction in parentheses, just a good habit. So 4/3 times the pi button times 6 now being raised to the 3rd power. So 6 cubed results in a volume of 904.8 centimeters cubed. Now remember, volume deals with, basically, think of it as how much can we put inside of this figure is kind of how you think about it. So that would be our answer for the volume of that sphere. Let's move on to the cylinder. All right, so based on this cylinder, okay, hopefully you can see that the circle shape is the base of the cylinder, okay? So we're looking for all three things: lateral surface area, total surface area, and volume. So what do we need to know? So first we need to know what the radius is, what is the height of the cylinder, and then B, which stands for the area of the base. So the radius is given to us as 21. The height is given to us as 30. Notice I went ahead and drew my base here. The base is a circle, so we have to know what the area formula is of a circle, which is simply just pi r squared. So to get b, we need to do pi r squared. So if we actually work that out, we're going to use the pi button in our calculator. Okay, so we're going to have pi times the radius, which is 21 squared. So 21 squared times the pi button leaves us with the area of that base being 1,385.4 centimeters squared. So this is our capital B. So let's solve our surface areas and volume. LSA, lateral surface area, is simply 2 times the pi button times the radius, which is 21, times the height, which is 30. All right, so 2 times the pi button times 21 times 30 gives me a grand total of 3,958.4 centimeters squared. Now for the total surface area. Remember, total surface area, the first part of the total surface area uses that exact same value from the lateral surface area. So there's no point in me having to rework it twice. So that's 3,958.4. Plus, we're adding 2 times pi r squared. Well, hopefully there's something you're recognizing here. Pi r squared, that's actually capital B. So we could almost rewrite the total surface area formula for a cylinder to be, for that to just really be plus 2b. That's essentially what it is. So when we work this out, we get 3,958.4 plus 2 times b, which was the 1,385.4. And all right, when we do that all in our calculator, plus 2 times 1,385.4, we get a total surface area of 6,729.2 centimeters squared. Now for the volume. Volume is simply capital B times H, which we know capital B is the area of the base, which is the 1,385.4, times the height of our cylinder, which was 30. So 1,385.4 times the height of 30 gives us a grand total for the volume of 41562 centimeters cubed. All right, now let's move on to the cone. Okay, so notice the cone has only one shape as its base, and that hopefully is kind of obvious, and that's the circle here. Okay, so we're going to look for lateral surface area, total surface area, and volume. So based on the formulas that I have already all written out, a few things that we need to know. We need to know R, which is the radius. We need to know L, okay, cursive L, okay, which is in reference to the slant height. So notice we actually don't have to know what the legit altitude is. We actually need a slant height here, okay, that diagonal. And we need to know B, capital B, which is the area of the base, which is a circle. So the radius is given to us as 8 centimeters. The slant height is also given to us as 12 centimeters. And then the base, or area of the base, is not given to us. We actually need to work that out. So I redrew, as you can tell here, the base. There's only one, okay? And we're going to use the area formula for a circle, since that's what the base is, to figure out capital B. So the area here is going to be pi times, and for this one, I'm going to make it a little bit different. So I'm actually going to tell you guys that for pi, we're actually going to use 3.14 instead, okay? So pi times the radius, which is 8, squared. So in other words, 3.14 times 8 squared. All right, so we got, when we work that out, we get, based on rounding to the 10th, we're actually going to end up with the area of the base being 201 centimeters squared. So capital B is simply 201. Now that we know that, let's get started on finding the surface areas and volume. So, starting off with the lateral, the formula is pi times r times the slant height. So when I plug this in, we got 3.14, which we're using for pi, times the radius, which is 8, times the slant height, which is 12. So 3.14 times 8 times 12 gives me a grand total for the lateral surface area to be 301.4 centimeters squared. Now let's look at the total surface area. Again, the first part of the total surface area is the exact same as the lateral, so I'm not going to rewrite that twice. We already know that answer is 301.4. And from that, we're going to add pi r squared. Now I want you to think for a minute here. Pi r squared is capital B. It is the area of the base, okay? So we're simply just adding B here, which means we have 301.4 plus capital B was 201. So if we add 301.4 plus the 201, we end up with total surface area being 502.4 centimeters squared. Now the last one, volume. Volume is 1/3 times B, which is 201, times height, and the height, well, we don't have the height, do we? So for this case, we actually do have to figure out what that height is. Now, the nice thing is when I draw that altitude in, okay, this creates a right triangle, and we know two of its sides are 8 and 12, so we can figure out the height by using Pythagorean theorem. So if we use Pythagorean theorem here, a squared plus b squared equals c squared, I got 8 squared plus b squared equals 12 squared. That gives me 64 plus b squared equals 144. I'm going to subtract 64 to both sides. So I'm left with b squared equals 80. Take the square root of 80. And yes, we're not going to keep it in radical form, okay? We're going to get decimal forms for this. And you would get 8.9. So the height of this cone is 8.9. So make sure you do not use the slant height, okay, when you're doing volume. Very important, okay? So we get 8.9 for the actual height. So now when I multiply 1/3 times 201 times that actual height of 8.9, we get the volume to be 596.3 centimeters cubed for that cone. Now we're moving on to a pyramid. So let's write all our formulas we need. All right, so looking at this pyramid here, we can see that it only has one base, okay, which is this shape down here, which is that square, okay, and we see that we're given one of the sides of that base, and we're also given the slant height. So for our formula, what we need, for all of our formulas, what we need is, we need to know our slant height, we need to know P, which is the perimeter of the base, we need to know B, which is the area of the base, and we actually also need to figure out what the height of it is. Okay, so let's deal with the first three first. The slant height, that's an easy one. That's given. It's 12. Now to find the perimeter of our base, notice I took the time to redraw it. They tell us that based on the markings there that the base is a square, so therefore simply just doing 15 times 4 or 15 plus 15 plus 15 plus 15 gives me the perimeter to be 60. All right. Now the area of the base, simply just base times height, which is going to be 15 times 15. And that gives us 225. So that's 225. Now, the trickier part here is trying to figure out what the height is. Now, you got to have an eye for this kind of three-dimensional eye. If I were to draw this in, and I drew a new slant height right there, you can see I have created a right triangle inside of that pyramid. Okay, so that's kind of what we're going to have to go off of here in order to figure out what the height is. So in drawing that right triangle, we know that that slant height was 12. We have no idea what this height is. That's what we're trying to figure out. But notice, I know I'm not going to be using the full 15 here. I'm only going to be using half of it. So that means that this portion is only 7.5. So now I'm going to use Pythagorean theorem to help me solve this. So when I plug that in, I get 7.5 squared plus b squared equals 12 squared, since we actually already know that. So 7.5 squared is 56.25 plus b squared equals 12 squared, which is 144. All right, got to solve. So I'm going to subtract this 56.25 to both sides. So 144 minus 56.25 results in b squared equaling 87.75. Last step, don't you forget it, is to take the square root of that. So if I take the square root of 87.75, we get the decimal answer of b having to equal 9.4. So our height is 9.4. Now that we know all of those components, we can actually solve these problems. So the lateral surface area is 1/2 of P, which was 60, times slant height, which is 12. So half times 60 times 12 results in 360 centimeters squared. Now let's look at the total surface area. Again, notice that the total surface area's first part is the same as the lateral surface area. So no point in reworking that twice. We already know that answer is 360. Okay, plus B, which is 225. So 360 plus 225 results in the total surface area being 585 centimeters squared. And last but not least, volume is 1/3 times capital B, which is the 225, times the actual height, which we discovered using Pythagorean theorem, was 9.4. So we do 1/3 times 225 times that 9.4 height of that pyramid, we end up with the volume of 705 centimeters cubed. I know this is a lot of work, so hopefully you don't find it too difficult since we're using all formulas here, but I know it's a lot. All right, this next figure, do not get confused here, okay? This is actually a prism. This is a triangular prism, though. Notice what it's sitting on, that rectangle shape that it's sitting on, is not the base. A triangular prism's base will be the triangles, because notice there are how many of them? 1, 2. And you can note that, and the reason why I can clearly tell you that is if you look at the total surface area formula, it's 2 times B, meaning that there's 2 bases. So that's why we have to use, in this sense, this triangle, okay, these two triangles are the bases for this particular prism. So keep that in mind. I'm actually going to have you guys work this problem OYO style. Okay. I already did write out your formulas. I kind of helped you guide you in what it is you specifically need. I even redrew the base itself. Okay. So you guys should be able to handle that. So we're going to move on to the hemisphere. Okay, so as you can see here, I already wrote that the lateral surface area is non-existent for a sphere or hemisphere, so I put NA. So all we have to find is the total surface area and the volume. Now I know the radius is in an odd position, but as long as it's not at the actual center, I guess we would call it essentially, that is considered the basically the height of it. So as long as it's not that line, then the value that they actually gave us is still considered a radius. Okay? So please do keep that in mind. Because the only piece of information we need is to know the radius. And in this case, it is actually 18. So to find the total surface area, we were going to have 2 times pi, and we're going to use the pi button here, times the radius, which is 18, squared. So when I do that, 2 times, make sure you're using the pi button, not 3.14, times 18 squared, we get a total for the total surface area of this hemisphere to be 2,035.8, not centimeters, millimeters squared. And volume now is simply 2/3 times the pi button times this time the radius being cubed. So when we do that, the volume, so the amount that we can actually fill into that, is 12214.5 millimeters cubed. And that sums up surface area and volume for all of the different three-dimensional figures, polyhedrons, that we are going to be dealing with this unit.